Welcome back to Chemistry Matters. Were you able to identify the unknowns? Double-check the flow charts you drew to confirm how many steps you used. Let's check in with our students and see how they did.
Okay, does everyone have the results of their lab?
We do.
Us too.
All right, how about you guys? Let's take a look at your flow chart on the monitor here. Would you please explain your conclusions and the steps that you took?
We ran the test in the order of the flowchart we created. Unknown number 1 was the only one insoluble in water, which tells us that it's calcium carbonate.
Then we mixed unknowns 2, 3, and 4 with the sodium chloride solution. Unknown number 4 produced a white solid precipitate.
Looking at the solubility table, we identified unknown 4 as lead-2 nitrate because lead-2 chloride is insoluble.
Next, we used hydrochloric acid to test unknowns 2 and 3.
Unknown 2 bubbled up, which we think is the carbonate turning into carbon dioxide, so unknown substance number 2 must be sodium carbonate.
Which means unknown number 3 must be potassium iodide.
But we tested with the lead-2 nitrate just to make sure, and it made a yellow solid, which we know is lead-2 iodide.
Great work and analysis, you guys. How about you? What were your results?
Well, we got the same results, but our process was a little different. So since the second goal was to try to use the least number of steps, we tried to figure out what information each step could give us.
We only use each test once. How could you do it in fewer steps?
Well, when we looked at the tests, we realized we didn't have to use every test to figure things out.
Right. First, we used hydrochloric acid on all of the unknowns.
We got a white solid and 2 samples that bubbled. Then we looked at the solubility table and identified unknown number 4 as lead-2 nitrate because of the white solid precipitate.
We knew unknowns 1 and 2 had to contain carbonate because of the bubbles, so we used a solubility test on unknowns 1 and 2.
Since unknown number 1 was insoluble, we knew it was calcium carbonate, which means that unknown number 2 had to be sodium carbonate.
And the only one left was unknown number 3, so we figured it must be potassium iodide.
So you only ran one test on unknown number 3. Is there a test that you could have run to identify that further?
Well, we could have taken the same last step as the other team using the lead-2 nitrate solution.
Yeah, if we're correct, that would have given us the same results.
Great work, all of you. What you've done is you've demonstrated that there's more than one path to the correct answer. So can you guys think of a job in which this kind of chemical testing might be used to identify unknowns?
I was watching a movie last week and they showed a lab with an FBI technician testing some drugs with a colored test kit. Different colors meant different drugs.
And that's a great example because forensic scientists often use a wide variety of tests to identify drugs and other evidence.
In addition to criminal investigation, like our student just mentioned, there are lots of jobs that use chemical testing. For example, when you have your blood tested at a doctor's office, the technicians probably look for some chemicals you're familiar with, like sodium, potassium, iron, oxygen, and cholesterol. Agriculture specialists know how to test soils for nitrogen, phosphate, sulfur, and potassium. Atmospheric scientists test chemicals in the air, while oceanographers test chemicals in seawater. Car mechanics can test batteries for sulfuric acid and can find combustion products in automobile exhaust. So how did you do identifying the unknown chemicals? Did your answers match those of our students? Did you figure it out using only 2 tests? You've learned a lot about chemical reactions, balancing equations, predicting products, and putting it all together to identify unknowns. And the Unit 5 Toolkit contains several helpful resources for this unit, including an activity that explains how to predict the products of a reaction and name the products following IUPAC guidelines. Of course, you can always check out the closer look videos for this unit if you want to dig even deeper. When you're ready, I'll see you at the top of the Unit 6 playlist, where we'll use chemical equations to calculate the amount of reactants needed for products to form. It's one of my favorite parts of chemistry.